All right, well, I've got another interesting looking Sudoku here today that I found on Logic Masters Germany. This is called Square Watermelon by Bees. And the question mark there is not to indicate that I'm not sure who it's by. That's their username is Bees with a question mark. So that's how I'm going to stick with it. Bees with a question mark. So maybe they're not sure what their name is. I don't know. At any rate, this one caught my eye because it has an interesting thing with these rings, and I've done not something exactly like this, but kind of something similar before in a puzzle where I had sort of different rings and different rules applied to the different rings. And so I thought this would be interesting. All right, so rules are, by the way, we don't know the difficulty of this one because it doesn't have enough ratings on Logic Masters Germany yet, but the setter has estimated it at 3 stars out of 5. So take that with a grain of salt, I guess, for what it's worth. It's hard to judge your own puzzles, but that's all we've got. Rules are normal kropki stuff. So the black dots are ratio dots that are 1 to 2. So any set of 2 cells, it could be 1 and 2 or something, or 2 and 4 or something like that. The white dots have to be consecutive digits, so maybe 6 and 7 or something. Now the interesting part here, these cages are not killer cages, right? I mean, obviously this one is way too big. You can't have killer cage that big. What the cages are, or these rings, if you want to call them that, are the negative constraint only applies within the ring. So we have a white dot here, which means these have to be consecutive. There's no dot right here, so these two cannot be consecutive. However, these two can be consecutive because they're in different rings. The negative constraint only applies to the adjacent cells within the ring. So within this ring, you would have a negative constraint as well. And within this ring, and in here. So I think that sounds pretty interesting. It's a neat idea. I'm going to give it a try now, and link in the description as usual, and we'll see how it goes. I'm going to reset my timer. So, I mean, just like any kropki, the first thing I'm going to do is look at these areas where you have a chain of 2 black dots, because it has to be 1, 2, 4 or 2, 4, 8 in some order. The only other thing you can put on a black dot is a 3, 6, but if you did 3, 6, you'd have a 3 again. So if you do 3, 6, these two are going to be repeated. We can do that down here as well. And then, what are we going to look at next? I guess down here maybe, because I always look for longer chains of dots because it's going to be more limited in what you can do. So let's see. You could do 1, 2, 3, 6. You could do 2. You can't do 2, 1 because then you'd have to do 2 again. So 2, 4, 3, 6, or 2, 4. Yeah, it'd have to be 3, 6. You can't do a 5 on a black dot. You could do 3, 6. Then you'd have to have a 5 or a 7. So you can't do 3, 6. You could do, well, oops. Let's just keep going in order. 4, 2, 3, 6. 4, 8 would have to have a 7 or a 9. You can't do that. So 6, 3. Right. So essentially, I'm not going to do the 6 right now because we've kind of done that backwards here. Just by filling these in, we've done the 6, 3. And what could happen here? So then you could still have 8, though. You could have 8, 4, 3, 6. So it's like this or the reverse. So I'm going to fill in 6 and 3, 2, 4, 1, 2, 4, 8. So those are the options there. There's more options than I was hoping for. But one thing I do know is there's a 3 right here. Because this can't be 2, 4 because of the white dot. So there's definitely a 3 right there, which means this can't be 3, 6. So this is 1, 2, 4, 8. Right, so there's a 3 down here, but there's also a 2 or a 4. So this can't be 2, 4, right? We couldn't do something like that. Um, and so knowing that it can't be 2 and 4, well, it also can't be 1 and 8, right? So there has to be a 2 or a 4 on there. And there's a 2 or a 4 on here, so this can't be 2, 4, I think. Is that right? Yeah, that's got to be right. So then, how does that affect over here? 8, 4, 3, 6. So you can still get 6 there. 6, 3, 2, 1, 6, 3, 4, 8. 1, 8, and 6 here. Can you have 2 or 4 here? 2, 3. 2, 4, 3. Yeah, you can. Because you can do 2, 4, 3, 6, or 4, 2, 3, 6. So those are still all possible there. Okay. I didn't know if taking the 2, 4 out of here would remove some options on this side. But, so we now know that we've used up our 3 in the column. We've also used 2 and 4, so this has to be 1, 6, or 8, I guess. Which means this is 2, 3, or 4. So that's still, I think that's still possible though, to not have 3, 6 here. You could have 8, 4 with 1 and 2. You could have 1, 2 with 8, 4. Or you could have 3, 6 there. All right, what about over here? We've got the 1, 2, 4, 8 quadruple here. So this has to be 3, 5, 6, 7, and 9. This one can't be 3 because it's next to a 2 or a 4 in this ring. Actually, there'd have to be... Oh, we can't put a 3 here either, because remember we had the 3 down here. So there's a 3 in one of these, which means this can't be 2 or 4. So that makes this a 2 or a 4, because it's either 8, 4, 2 or 1, 2, 4. Then we got a 2, 4 pair right here. If that's a 5, it would give us the order. Can this one be a 3? This can't be a 3 because it's next to a 2 or a 4. So that gives us... No, that's not true. Remember, the negative constraint only applies within the ring, not across here. So that can still be a 3, actually. But one of these two is a 3, which means that's not a 3. So this isn't a 6. Because the 3 is in one of these, so that's not a 6. So now we've got 2, 4 pair here, which gives us a 1, 8 in that cell right there. So this can't be 1, 2, 2, 3, 3, 4, 4, 5. It could be 5, 6, or 6, 7. It can't be 7, 8, or 8, 9. So it's got to be 5, 6, or 6, 7. There's a 6 in there. And now we've got 1, 8. So we know there's a 1, 8 here. There's a 1 or an 8 in this thing because it can't be 2 and 4. So it has to have a 1 or an 8. There's a 1, 8 here. That's sort of a 1, 8 pair, which means this is 6, I think. 2, 4, which is then going to be 1, 2, 4, or 8. Okay, so these are not 6. This is 5, 7, or 9. Ah, the 6 means this has to be the 9. So these are not 9. This is either 1, 2, or 4, 8. If it's... Oh, but it could be... Yeah. I was gonna say that one of these is a 7, so it can't be 4, 8, but it can be because you could have 7, 4, 8, 5, for example. Oh, but the 2, 4 pair here. That can't be a 2 or 4. It's not a 1 or an 8. So now we've got a 1, 8 pair, 2, 4 pair. Okay. And I'm not seeing. So whichever one of these is 8 is going to have the 5 next to it. But that seems okay. I don't see why that would be a problem. 1, 8, 3, 5, 6, 7. So there's definitely a 3 in here. There's definitely a 6 in one of these. Okay, let's see what we can. Maybe we can do something over here. So this could be. I mean, 1, 2, 4, and 8 are still possible. If it's 3, 6, it has to be in this order because of the 6, 3 over here. 3, 6. This would have to be 5 or 7. That seems possible. Okay, what else can we do? Can we do anything with this one? So we can't use 2 or 4 or 3. 3, 4. So 5, 6, 7, 8, 9. Because it can't be a 1 if you can't use a 2. It's got to be 5, 6, 7, 8, or 9. But that's a lot of options for consecutive digits. How about up here? What do we got? There's 3, 5, 6, 7, 9. And there's not a 6 in those because we know the 6 is on the white dot. So the 6 can't be next to the 3. We know that much. So, but we don't know which one has the 6. Oh, the 2, 4 can't be next to the 3, so that's not 3. So the 3 is in one of these two. If that's 8, it would get rid of the 7, 9, but we don't know that yet. 5, 6, 6, 7. So wherever the 3 is, the 6 is going to have to be, you know, on the opposite side of the white dot. Okay. Don't think we know yet. There's 3 here, 3 here. There has to be a 3 up here. But again, that doesn't really do much for us unless it's right here and we can remove a 6, but or if it's right here and we can remove the 6 from there, actually. 1, 8, 2, 4. Okay, so 3, 2, 1, 3, 4, 2, 3, 2, 4, 3, 4, 8. Yeah, so those are all still possible there, I think. So this can't be 8. If this is 8, it forces a 1 there. But if it's an 8, it also makes this a 4, 2, 1. So it would have you'd have 1s in both of those. So this can't be an 8. Can it be a 1? Maybe it does the same thing. 1 would put an 8 there. It would also do 2, 4, 8. Yeah, so this can't be a 1. So this is a 2, 4 pair. That's interesting. Now we've got a 2, 4 pair here. What's in here? 1, 5, 7, 8, and 9. Is that going to be helpful? Kind of actually. Okay, let's okay, I'm gonna delete those. Um, Here's the thing to look at. 3, 6 is in here, right? And it's in there. So the 3 and the 6 in column 7 can't be in any of these, can't be there. They're in these 3. Now, we can't put 3 and 6 in these 2 because they'd have to have a black dot. So one of them has to be up here. Because you can't put 3 and 6 in here. So the only way to not have a negative issue is if that's a 3 or a 6. And if that's a 3 or a 6, now you can't have a 6 right there because of it would either this is a 6, which removes the 6, or this is a 3, which would need a black dot then. So that can't be 6, which means this can't be 5. I don't know what that does for us, but it's something. uh, if that's a 6, then you have a 3 up there. Now, normally when you have two digits that can't be next to each other, like a 3 and a 6, limited to 3 cells, you can remove them both from the middle one. But not in this case, because we can have 6, 3 right here, for example, or 3, 6. So unfortunately, we can't remove them from there. Or at least not yet. Maybe eventually we can. Oh, this can't be this is a 2, 4 pair. 8, 4, 2, 1, 2, 4. This is a 2, 4 pair. So these cannot be 2, 4. And they can't be 1, 8. Okay. Yep, this is what I should have seen earlier. They can't be 1 and 8, so they have to be 3, 6. And now we've got 3, 6 pairs here. There has to be a 6 and a 3 in here. And this time we can use that trick to remove the 3 and the 6 from the middle. Because if you put a 3 or a 6 here, you can't put the other one next to it. And they both have to be down here because of these. And this can't be a 3 because it would have to have a 2 or a 4 next to it. And we've already got a 2, 4 pair. So this is 6 and 3, which is going to give us our 6 up here and then our 3. These 6 can't have 5 or 7, so that's the 9. 6. There's a 6 over here. But I don't know. Yeah, we don't know where yet. Okay, this is 5 or 7, and this is 5 or 7. So what do we have left here? 1, 8, and 9 to complete the row. And one of these two is a 7, which means that one can't be an 8. 8, 9, 3. Okay. These are going to be 1, 2, 4, 8, and 9. We have to avoid the 1. So the main issue, I'm going to remove the 9 just for a second. The main issue is the 1, 2, 4, and 8 through here because we have to avoid the dots. So I'm thinking yeah, I don't think this can be a 9. Because if this is a 9, this is a 1, you'd have 2, 4, 8 in here. And there'd be no way to avoid the 4 being next to a 2 or an 8. So this can't be a 9. Could this be a 1? No, because you'd end up with a 9 there. Same problem. So this has to be a 2, 4, or 8. But I don't think we know more than... Oh, but we also have to avoid the 8 and the 9 together, don't we? So if the 9 and the 8 were both in here, they would have to be kind of in corners. 9 and 8. And then, but then you could put a 1. Well, the 1 would be down here. You'd have to have a 2 there then, wouldn't you? But you could do that. 8 and 9 with a 2. Yeah, that's possible. Okay. I delete those actually. That's too many digits to be helpful. But we know this is a 2, 4, or 8. If it's 2, it would have to have a 1. A 4 would have to have a 5. The 8 could have 7 or 9. That's a lot of options. Okay, that's not very helpful yet. Maybe at some point it will be. All right, so what do we look at next? Where do we look next? These are 1, 5, 7, 8, and 9. Oh, we have a 5, 7 pair. And now this has to be 8 and 9. The only way you can make that work is with 8 and 9, which gives us the 1 and the 8 and the 4 and the 1 and the 2. And this is 2 and 4 and 2 and 4. All kinds of stuff. These can't be 3 and 6. So the only place to put 3 and 6 in column 8 now is right here. Which means these are 5, 7 pair. And so now the 3 and the 6 are up here. 5, 7 means this can't be a 6, so it has to be the 3, the 6. This 4 means that has to be a 7 and a 5, a 7 and a 5 and a 7. And the 1 over here gives us 8, 4, 2. And now we are moving along. Cooking with gas, as some people would say. 5 and 7 there. 1, 8, and 9. This can't be 8 because it's next to a 4. Oh, and this can't be 8 because it's next to a 4. This has to be the 8. Now this has to be the 8 in row 9 because we had the 1, 9 pair there. 8, 8. So there's an 8 up here, and it can't be right there. So this has to be the 8, which gives us a 7 or a 9 right there. The 8 here can't be next to a 7. 5, 7. 7 can't be next to a 6. 4, 1, 3. Okay. That 7 gives us the 9 there, which gives us the 1 and the 9 here. Now, we don't have very many options in here, right? So 2, 4, and 5. So these obviously have to be the 4 and 5, which gives us the 2 there. 1, 2, and 7 in here. This one can't be 7. That one can't be 7 because it's next to the 8. So you get the 7 in the middle. You could also put the 7 in the middle because the 1 and the 2 need to not be next to each other. So the 7 is going to have to sort of chaperone the dance here and stay in between the two people. Don't want to get too close to each other. 2, 3. These are 4 and 9. The 4 can't be next to the 2. And now the 2 can't be next to the 4. So we get that. This is now 1 because the 9. Don't know on the 5, 7 pair yet. Let's see, what can we do up here? All right, let's look at this row. 1, 3, 4, 5, 8, and 9. 9 can't be in here. And so now we can't put a 1 on here. It'd have to have a 2. We can't put an 8. It would have to have a 7 or a 9. So it's 3, 4, or 4, 5. So there's a 4 in there. These are not 4. These are also not 3 and 8. So we get 1, 5, 9. 3. So this is 3, 4. Or 4, 5. If it's 4, 5, this is 3. If it's 3, 4, then the 5 could be in a lot of places. Okay. Oh, the 6 can't be next to the 5. Of course. 4. Okay. Yeah. Oh, the 1 9 here gives us a 5. There we go. And that makes this a 3 4. That's not 3. 4 can't be next to the 8, but we don't know if that's an 8 yet. If that was an 8, then we would know. Do we know? 3 4 1 8. Nope. 1 9. Nope. Okay, so what do we have left here? 2 3 4 6 and 7. So this either has to be 3 4 or 6 7. Oh, this one can't be 3 and 4. So now this can't be 6 and 7 because it would use both of those options. So this is, and this also can't be 3 4. 6 7 3 4 6 7. The 5 means this is the 7 and the 6, and the 6 can't be next to the 3. So we get all of that. Now these are 1 6 and 9, and there's definitely a 6 in here. This one can't be 1 because it's next to the 2. So there's a 1 here. It's a 1 over here. So we got 1 5 7 8 9. Oh, this can't be 6 because of the 6 down here. This is 9 1 6. The 1 gives us 8 9 8. These are 1 2 and 5. The 1 and the 2 can't be by the 3. Uh-oh. No, that's wrong. I know how counting works. The 2 cannot be next to the 3. But also, the 1 and the 2 cannot be next to each other, so the 5 has to chaperone the dance. 1 2. All right, over here. What are we? We were doing this, and then I got distracted. So this can't have a 9. Has to have a 1 and an 8. The 8 can't be next to the 9. This. So definitely has to have a 1 and an 8. Okay, so the 8 is in one of these two, which then means the 7 can't be in either of those, because whichever one the 8 is in, the 7 can't be next to it. So, oh, and the 1 5 here gives us an 8. And then this can't be 7 because it's next to the 8. So this has to be the 7. Gives us a 5 there. 1 and 5, I think. Those are all good there. What do we have left here? 2, 7, and 9. The 7 and the 9 cannot be by the 8. And the 7 can't be by the 6. So that gives us the order of those. Now I feel like we're approaching the end of the puzzle. 1, 2, 4, 5, and here these can't be 5, obviously. It's got to be 1, 2, or 2, 4. Oh, and the 2 there gives us a 2 right there, and the 1 there gives us a 4. So this is not 4. We have 1, 5. Oh, and the 1 can't be next to the 2. So we get 5, 1, 5. Let's see, what do we, oh, the 4 there is going to give us 5 and 4, and that 4 is going to give us 3 and 4. And these are hopefully consecutive digits, 6 and 7, yep, which have to be in that order because of the 7 and the 6 over here. We have 3 and 9 left in the middle, which have to go in that order, and 1 and 8, which have to be that way. Timer turns green. There we go. That is Square Watermelon by Bees. I assume you have to say it like a question since it has a question mark on it. That was a really cool puzzle. The trying to remember the negative constraint only being on the rings and not across the rings was a little bit hard to remember sometimes. A couple times I felt myself saying, "Oh, this can't be here," or things like that, and that's not true. So, cool idea. Square watermelons are kind of neat. Anyways, they just look weird. I've never seen one in real life. We don't have them here where I'm from. So, and I don't really like watermelon. Anyways, I know most people do, but my wife does. My wife enjoys watermelon. But anyways, that's not really relevant to the puzzle. That was a fun puzzle. Thank you, Bees, for that puzzle. I'm gonna go record my solve on Logic Masters Germany and see if we can get it up into the red star territory where it has an official rating. I think 3 stars for difficulty is about right. Maybe even a low 3. It wasn't too bad. There was never any spot where I really felt stuck. It was just kind of where do I look next. And if I'd noticed the one or the what 2-4 right here pair that would give us the 3-6 earlier, then I think I would have been a lot quicker. But I kind of got stuck looking at this area over here. But anyways, hope you guys enjoyed that puzzle, and I'll see you again soon with some more. Thanks. Bye.